Okay, so not many have joined. Okay. Anyways, we'll start. Okay. So we will start with basic some revision. Okay. I hope people will join in next 3-4 minutes. So let's revise something till then. Okay, everyone. Okay. Tell me, Manoj. So let's have a recall test. Okay, so we have few simple problems. So unlike an isolated atom, the energy level of electrons in outermost orbit will be different in each atom for closely packed crystal. True or false? Tell me, true or false? Okay, okay, Manoj. What about you, Radhika? Tell me. Varsha? Okay, very good. Second, an intrinsic conductor, right, will behave like an insulator at 0 Kelvin. True or false? Okay, very good, Manoj. Third, the relative size of dopant atom should be lesser than, greater than, similar to. It's quite easy, right? Tell me. Relative size. Okay, very good, Manoj. Fourth, with the fall of temperature of semiconductor, the forbidden energy gap, fall of temperature, right? Fall of temperature. The forbidden energy gap will increase, decrease. Okay, very good, right? Yes. Fifth one, in the PN junction, the potential barrier opposes the motion of, tell me, PN junction, right? So barrier potential, okay, it opposes the motion of what? Think about it, everyone. Chemistry, Kalpana, Radhika, tell me. Fifth one, anyone? Okay, think about it, not think about it, right? When we talk about PN junction, okay, the barrier potential, when you talk about barrier potential, so electric field is from N side to P side, right? Yes, okay. So the answer is D, okay, because it opposes the motion of electron from N side to P side because it attracts the electron from P side to N side, right? Got it? Okay, tell me guys the answer of this concept test. Which, which is the highest gain provided by CE configuration? Think about it. Tell me guys, what do you think? What's the answer? Okay, so this is what we will study now. Okay, so I guess around 11 students have joined. So obviously you couldn't have answered this because you don't know, right? But you can just intuitively think about it. When we talk about C configuration means common emitter configuration. Okay, both current and voltage will increase. Yes or no? Tell me. Both current and voltage will increase, right? Okay. Now we have four options. What is the definition of power? Tell me, guys. What is the definition of power? Tell me. Think about it. VI. Now, if V is also increasing, I is also increasing. So highest increase should be in which parameter? Tell me. Got it? So for this, you don't have to know the formula. You just have to think intuitively, right, everyone? We will see how much it will increase, right? What is the power gain? Okay, but this is just an intuitive answer, right? Got it? So it will be powered. So we will see now, okay? So let's see. I've already written this for you guys. Okay, so this is your common emitter configuration, right? This is what we were talking in the first class. I hope everyone remember this common emitter configuration. Okay, so this is your supply voltage. I have just connected the resistance, load resistance. Okay, so I can say that this potential between these 2 points will be my output voltage. Yes or no? Tell me. Output voltage. Yes or no? Between point A and B. A and B. Okay. Okay. Now we know Kirchhoff's current law, Kirchhoff's voltage law. We will use whatever we have studied till now. Now, when we talk about this common emitter circuit, okay, this is your common emitter. So I know this IC plus IB is equal to IE for all the circuits. Doesn't matter it is common emitter, NPN, PNP. This is true for all the circuits, all the configurations, right? And we also studied two relationship. Okay, we studied that IC by IB is equal to beta. IC by IB is equal to beta, and IE is equal to alpha into IC. Alpha into IC. Okay, this is your second relationship, right? Because if you put the value, if you put this value, you will get a relationship between IE and IC. Yes or no? Just try to put the value of beta over here, right? Just try to put the value of beta over here. You will get a relationship, okay, in terms of beta, okay, right? So after solving this, you will get alpha is equal to 1 plus 1 by beta or 1 plus beta by beta. Okay, so basically alpha is your current gain in common base configuration. Okay, in common base, right? Sorry, common collector configuration, right? So we won't be worrying about this. We will be just worrying about common emitter configuration. Okay, so current gain is output by input, output current by input current, output current is collector current, and input current is base current. As simple as that. Okay, right? Okay, now we should remember that when we talk about this circuit, right? When we talk about the circuit, okay, we have two equations. One in terms of IC, which is your output current, and RL, which is your load resistance, and one in terms of input current, which is IB, okay, and input voltage, which is VIN, right? Now let's try to write the equation using Kirchhoff's voltage law. So I can write this equation, right? VIN at this point, VIN minus VBE, VIN minus VBE, right, is equal to IB into RIN. Yes or no? Tell me. Yes or no? Tell me this one. Agree? Right? VA minus VB is using Ohm's law. Change in potential between point A and B should be equal to current into resistance. Okay? Right? Now, out of this, VIN and VBE, which is constant? Tell me. Which is constant? Out of VIN and VBE, which is constant? No, VIN we are giving, right? VIN is changing now. Tell me, when we talked about characteristic, okay, when we talk about characteristic, it is between VIN, right? VBE is constant, now VBE is constant, okay, because this is your input voltage, right? VBE is the potential barrier between this PN junction, which is constant, right? Potential barrier will not change now, right? Got it? Got it, Harsha? Okay. So potential barrier is constant for given semiconductor, for given this PN junction, it is constant. So VIN, which is the input voltage, minus VBE will be IB into RIN. Okay. Now, if I want to find the change, right, since this is constant, then change in VBE will be 0, yes or no? Change in VBE will be 0. So can I say that delta VIN is RIN into delta IB? Tell me, can I say this? Okay. So this equation I got, from input circuit, right? Okay. Or RIN is basically delta VN by delta IB that we'll be using. Yes, input resistance will be constant, no, Manoj, right? Obviously resistance are constant, right? Because we are using constant resistance, no, it's not variable resistance, right? We have never used variable resistance, at least in our syllabus. Okay, so I hope everyone is clear about this input, change in input voltage with respect to change in input current. Okay. Okay. Now, what about output voltage? So we know that VCE is your output voltage. Yes or no? VCE is your output voltage. Agree? Okay. So I can say that potential at point A is VCE. So VCE is equal to, right? So I can say that VS, this potential drop, VS minus VCE is a potential drop between this resistance. Vs minus Vce is potential drop between this resistance, yes or no? Right? Now tell me, supply voltage will be constant or Vce will be constant? We have already discussed this. I've already told you that which of the two will be constant, supply voltage or supply voltage. Yes, very good, Harsha, right? So supply voltage is constant. We are giving supply voltage, okay, right? So this is constant. Now, if I want to find the change, so since delta Vs will be 0, can I say that minus delta Vce is equal to RL into delta IC? Tell me, can I do that? Can I do that? Step by step, right? Makes sense? It's easy. Till this point, it is easy. Everyone is getting this? Okay. Now we already know current gain. This is your current gain. This is already your current gain, right? Okay. Yes or no? Right? Okay. Now let's see. What about voltage gain? What about voltage gain? So when we talk about voltage gain, basically it is change in output voltage by change in input voltage. Yes or no? Yes or no? Right? So delta VCE is basically change in output voltage by delta VIN is basically change in input voltage. So basically it is giving my voltage gain, right? How much output voltage will change if we change your input voltage? Yes or no? Tell me, yes or no? Yes? Okay? Right, very good. Okay? Now, when I just divide this by this, take this negative sign over here, I'll get something like this. delta IC by delta IB into minus RL by RM, sorry, RIN, R load by R input? Yes or no? Now, we have this relationship. Wait, I'll just show you this. We have this relationship. IC is equal to beta IB. Beta IB. Now beta is a constant. So if I want to find change, delta IC, can I say that it is equal to beta into delta IB? Right? So delta IC by delta IB is nothing but beta, right? Now substitute this value over here. So delta IC by delta IB is nothing but beta, right? And this is minus RL by RIN. So this is your voltage gain. This is called your voltage gain. Voltage gain, okay? Which is beta into minus RL by RN, right? Minus RL by RIN. So what is the meaning of this? Tell me, what is the meaning of this? What is the meaning of negative sign over here? Tell me everyone, what is the meaning of negative sign? Direction or phase, right? Phase basically. So I can say that this will be out of phase. Yes, this will be out of phase. Yes or no? Right? And we have already seen, okay, we have already seen that out of phase means if input will be in positive cycle, the output would be in negative cycle. That's the meaning of out of phase, right? You have studied AC, right, Manoj? Negative sign represents out of phase now. Okay, got it, right? In wave optics, in wave, in AC, right? In all the three chapters, I know for like this is pretty much sure that you have used this word in phase, out of phase. Anyone? Vishnu, Shrihari, sorry, Harsha, we haven't used this word out of phase, in phase in any of these three chapters, because I guess it's very common term, I guess. Okay, so this is about voltage gain. Now what about power, right? What is power gain? Now when we talk about power, as I said, power is basically I square R or VI, doesn't matter, right? So I'm saying I square R, okay, because I want to find the output power and input power, okay? So output power is I square R by R into RL, yes or no, right? And input power is I square B into RIN, okay? Now the ratio of output power by input power, wait, my handwriting is horrible. I'll just write it again. Okay, so I can say that the ratio of P output by P input, right, will give me what? I C square into RL divided by I B square into RIN, right? See here it is increasing like multifold, right? It is the ratio in which it is increasing, okay? Gain is always, right, here gain, and when you talk about transistors, gain is always the ratio of output by input, okay? Got it? Because it is amplifying, na? The work is amplifier. Now what is the meaning of amplify? To multiply it many fold, right? So it is always the ratio, okay? So if you see this IC by IB, we already know that IC by IB is beta, so it is beta square into RL by RIN. Okay, as simple as that, right? Now this is quite simple concept that I told you, but again, this thing is not as simple as it looks, but for our syllabus we just have to worry about this. Okay, right? It is power gain, Vishnu. It is just power gain. Okay, right? Here it is just called as power gain. Okay. Okay. So let's see. Okay. So we have derived everything for with this circuit, common emitter circuit. Okay. We have derived everything for this common emitter circuit, right, everyone? This common emitter circuit. Now we can derive for common base and common collector also, but it is not in our syllabus, so we need not to worry about that, right? But we can just see how this will work. Now we will just see this common emitter that we have already studied now, and we'll try to relate this with common base and common collector. This is the configuration for common emitter, right? Okay, means both collector emitter as well as base emitter will be connected. Okay, now when we talk about this, the resistance, load resistance, right? Okay, or input resistance are both high. They are high, right, everyone? Because if you see the example that I have taken like kilo ohm. Okay, so they'll be high, right? Now, when we talk about current gain, it was output by input. Current gain is always output current by input current. You have to see which current is your output current, which current is your input current. When you talk about common emitter, output current is IC. Yes or no? Output current is IC and input current is IB, right? So if output current is IC and input current is IB, so obviously current gain would be IC by IB. Okay, now let's see common base. Common base. When you talk about common base, okay, what is the input current? Tell me. Input current is IE, right? Input current is IE and output is IC. Yes or no? Because base is common. No, base is common, right? Okay. Now, so I can say that here common for common base, right? Current gain is IC by IE. Yes or no? IC by IE. Now, if you remember before this class, like in last class, I've told you that this common base is not good for current gain. Yes or no? It is not good for current gain, right? Okay. Now, when we talk about common collectors, in common collector, base is your input and emitter is your output, right? The ratio is IE by IB, IE by IB. Now again, it is called some random like variable gamma. For example, here we have taken beta, so it is gamma, right? There's no reason why it is gamma. It is just taken as a variable. For example, here we have just taken as variable as beta. There's no reason that why we have taken beta, okay? Right? Now, this current gain is considerably almost equal to beta because we know that IE is almost equal to IC, right? Okay, so I can say that, okay, this common collector will provide decent current gain, not as good as common emitter, but it will provide decent current gain. Okay, now when we talk about voltage gain, same formula, input voltage by output voltage, sorry, output voltage by output voltage in case of common base, right? See, output voltage will be same, doesn't matter you take common base or common collector, sorry, common emitter, right? Because the output is collector only, okay, so it will be IC into RL only. But when you talk about input, in common emitter, we have input as base, so it will be IB into RI. But when we talk about common base, input is emitter, so it will be IE into RI, right? I hope all of you are getting this. Yes, Vishnu, alpha is almost equal to alpha. The value of alpha, when we study the value of alpha, will be almost 0.9. It will be between 0.95 to 0.99. Okay, right? In real scenario, okay, it might be even less than that, but it's usually around 0.9. Okay, right? Don't worry, we just have to worry about common emitter. Okay, but if suppose you get any problem, right, from common base and common collector, it's not that you should leave it, because if you compare almost all the configuration have same principle, right? You have to use same Kirchhoff's equation. The only difference will be what is your input, what is your output. So if you can remember your input and output, right, you can solve all the problems. Yes or no? Tell me, right? Okay, for example, for common base is common. So remove base, we have only collector and emitter. So collector is output, emitter is input in case of common base, right? Common emitter we have already studied. Common collector, so collector is common, so we are left with emitter and base. So obviously emitter will be output, base will be input. Okay, got it, right? Now the voltage will be out of phase only in common emitter. Okay, right? Apart from this, for other two, it will be in phase. So this might be asked in just as a theory. Okay, right? So I hope all of you remember this. These are the simple formulas. Tell me, guys. Yes. So let's try solving one problem. Okay, let's try solving one problem. Okay, now let's see what kind of problem will be asked. So if you can see the problem, right? You will get problems like this, just formula putting getting. Okay, it will be just formula putting getting. If you know the formula, it will be easy. Now, first example, if you see equal to 1 plus 1 by beta, as simple as that, right? Sorry, it's 1 minus 1 by beta, I guess. It will be 1 minus 1 by beta. Okay, yeah, right? So we know that IC is equal to beta IB and IC plus IB is equal to IE. Okay, we have already used, and IE is equal to alpha IC, right? Did I make some mistake or what? This only, no, it is this only. I made a small mistake, I guess. Wait, let me check. Because obviously alpha is less than 1. That's for sure. Alpha is less than 1. So alpha should be 1 minus 1 by beta, right? So alpha is equal to, okay, 1 by beta is equal to alpha minus 1 minus alpha. Beta is equal to, yeah, it's correct now. So we will get this, right? Yeah, I know. I remember what mistake I did. It is 1 by alpha, right? So basically, this is the relationship you can derive. Okay, now we know that beta is 50. Beta is 50. It is given. Okay, so if beta is 50, then alpha will be, just solve it. You'll get the value. Now you should always remember that alpha is always less than 1. Okay, alpha is always less than 1, right? So see, it is 0.98. IC by IE. That's the mistake I did. Sorry, guys. I did the mistake in writing the value of alpha because IC is less than IE, right, everyone? Right? This is the mistake I did. IC is less than IE now. Okay. So if IC is less than IE, IC should be equal to alpha into IE, right? This is the mistake I did. Okay, my bad. Okay, I was writing IE is equal to alpha IC, so that's a mistake that I did, right? Because IE is greater than IC. Okay, now, yeah. So if you substitute this one, you will get this relationship, okay? Because IC is beta IB. Now, when you use these two into IC plus IB is equal to IE, you will get this relationship, right? Okay. Okay. Now, second question. Now, when we talk about second question, right? Okay. Now, here IB is given and beta is given, and you have to ask to find IC. So, IC you can easily find, right? It is beta into IB. Okay. And IE is equal to IB plus IC. So, you already have IB, you calculated IC, just add them. See, this is formula putting getting, right? Now, question number 28, when you talk about question number 28, again, current gain is given. When we talk about current gain in common emitter, it is beta. Beta is 50 given, right? If the emitter current, right, this is IE, it's given. Now, if IE is given, beta is given, can you calculate IC? Because if beta is given, you can calculate alpha, yes or no? Tell me. If beta is given, you can calculate alpha, right? And you can calculate IC and you can calculate IB then. Okay, got it? So I was writing this correct answer, no? 1 plus, okay, it is 1 by alpha is equal to 1 plus 1 by beta, right? This was mistake I did. Okay, anyways, so I hope all of you got question number 28. See, these kind of question will be asked, okay, in an exam, only these kind of question will be asked. Now, when you talk about question number 29, let's see question number 29, right? It is quite straightforward. Beta is given, common base configuration. Here it is changed, common base configuration, right? What will be the maximum collector current for an emitter current of 5 milliampere? So we know that in common base, okay, right? Beta is 75 given. So can we find alpha? Tell me, can we find alpha? Right? Using the same formula will hold true, right? So after calculating alpha, we know that IC, right? There's a relationship between IC and IE. IC is equal to, in this case, alpha IE, right? Now, after calculating alpha, can I calculate IC? Doesn't matter, it is common base, common emitter, right? Okay, got it? Okay. So anyone have any doubt? Tell me, anyone have any doubt in this? Tell me, everyone. I've already shared this with you guys. I've already uploaded this in the Google group. So you can just go through it and solve all the problems. Okay. Now, there's one thing which I want to tell you. When you talk about gain, okay, especially current gain, right? Current gain. You might hear about two things, right? AC current gain and DC current gain, right? So I'm not explaining you what is the difference between AC current gain and DC current gain, but mathematically, I'll tell you what's the difference. Now, when you talk about this ratio, IC by IB, okay? IC by IB, okay? Now, this IC by IB and delta IC by IB, they're not same. They're not same, okay? IC by IB is your beta, right? We have already used, this is also beta, but this beta and this beta may be same, may not be same, right? Why is it so? Because when you talk about this ratio, it is called as DC current gain. DC current gain. say this, right? This is called as DC current gain. If you take the ratio, just the ratio of collector current to base current, it's called as DC current gain. Okay. But when you talk about the change, right? Change in current, right? The ratio of change in current with VC constant, you have to keep VC constant. Then that is called as AC current gain. Okay. Now you use beta for both, right? But this beta may be different, okay, because of this change. Okay. So I can say that this is the maximum value and this is the value which may be less than this. Okay. Got it, everyone? Tell me, got it? Tell me yes or no. Okay, so tell me if we have calculated a voltage gain, right? So that was AC voltage gain or DC voltage gain? Tell me. That was AC voltage gain or DC voltage gain? Yes, very good, Harsha. Anyone else? That was AC voltage gain, na? Right? AC voltage gain. Got it? And power also AC. And power also AC. Okay. So I hope all of you got this. All of you got this, right? Okay. So we have one small topic. Mostly computer students have already covered this, but for NEET students, we will be covering this logic gates. Okay. Now this is very easy topic. Very easy means very easy topic. Now what are gates? Tell me, what are gates? If I talk about gates, so what are gates? Anyone? Tell me, what are gates? Okay. So basically gates are, or in layman term, I can say that gates are switches, right? Gates are just like switches. Yes or no? Right? Okay, as simple as that. Gates are switches, right? Either it will be closed or it will be open. As simple as that, right? Now, when we talk about gates, we have only two input, right? When we talk about gates, we have only two input, either open or closed. So either 0 or 1. Okay. Now, depending on these two inputs and depending on the different configuration of transistors, we form different type of gates. Okay, right? We form different type of gates. They are NOT gate, AND gate, right? You can see here. Okay, NOT gate, AND gate, OR gate, NAND gate, NOR gates, XOR gate, and XNOR gate are called as universal gates. Tell me, which of them are called as universal gate? Because this question I have asked many times. It is NAND and NOR. Okay, it is NAND and NOR. NAND and NOR are called as universal gates. Okay, right? So let's see each gate one by one. Okay, let's see each gate one by one. Now, when we talk about the output and input, the relationship between output and input are called as truth table. Okay, right? Depending on the function, right? We have different truth table. Now, when we talk about not means whatever input you give, it will reverse it, right? So this is a complement. We have already studied in Boolean algebra for math students. So if I'm giving 0 as input, right, it will convert into 1. Okay, if I'm giving 1 as input, it will convert into 0. So this is quite simple. Now, and is basically A plus B, right? Input of A plus input of B, as simple as that. So and is A plus B. Okay, so if A is 0 and B is 1, sorry, and is A into B, my bad, sorry, A into B, my bad, everyone, and is A into B. Okay, so if A is 0 and B is 0, then X is also 0, right? Okay, and if A is 1 and B is 1, then only it is 1. right? If any of the two is 0, it will be 0. It will always be 0. Okay, right? Now NAND. What is NAND? NAND is just put a NOR gate. Okay, put a NOR gate, right, in front of AND gate. Then you will get NAND gate. Okay, so just reverse all the outputs of X. So it is X bar. So the output X bar is your output of NAND gate. Okay, right? Now OR gate. So OR gate is A plus B. OR gate is A plus B, means either A or B. So if any of the two, is 1, the output is 1. Okay, the output is only, right? Only if it is 0, 0, then the output will be 0. Otherwise, it will be 1, right? Because A plus B. Now it is just your switch, right? If both are on, it will be on. It's not that 1 plus 1 will become 2. Okay, so this is your OR gate. Now, if you put one NOT gate, again, if you put one NOT gate here, then it will become NOR gate, right? So the complement of X will become the output of NOR gate. Now, when we talk about this XOR gate, right? Okay, XOR gate. So if you think about the table, right? If you think about the table, what is this? When both are 0, it is 0. When both are 1, it is 1, right? Right? So if one is, any one of them is 0, okay, it is 1. So can I say that it is A B bar plus B A bar? Think about it. Yes or no? Because if A is 0, okay, and B is also 0, right? Then this is 0 and 0, 0. If A is 1, right? So this is 0. If B is 1, then this is 0. Then also it is 0. But if any one of the two is 0, then it is 1. So it is XOR is A B bar plus B A bar. Okay, right? Now what about XNOR? Again, whole bar. Okay, whole bar. Just put one not. Now, like, I hope all of you understood this truth table and all. This was quite easy. Okay, so this is the representation. This is the representation of XOR gate. Okay, in OR you just put one curve. It is the representation of XOR gate, and XNOR just put one circle over here in the output. Okay, right? So this is a truth table, and we'll be using this only. Okay, now let's see the module. So the question of this 25.2 will be very easy. Okay, I'll just go through the question. Okay. Now, first, any digital circuit can be realized by respective use of, tell me. We have already seen universal gate, right? Which of them is universal gate? Okay, got it. Next, second one. You can just see using the output, right? Second one, you can do all, right? With one, right? So 1, 1 output is, tell me. You can solve this, right, guys? This is OR. Okay, when it is curved, it is like OR. Okay, so let's see. Question number two. The three amplifier stages, each with gain 10, are cascade, right? Okay. What is overall gain? Again, it's quite simple. Tell me, what's the answer? B. 1000. Yes. So easy, right? There was one good problem. Okay. Yeah, this one. Okay, question number 10. Try solving question number 10, everyone. A common emitter amplifier, right? A common emitter amplifier has a voltage gain of 50. Okay, voltage gain given 50. Input impedance 100. Ri is 100. Output impedance 200. RL 200. The power gain of amplifier is. Tell me guys, what's the answer? See how easy this problem is. It is formula putting getting, right? Yes, very good, Harsha. Everyone? So V output by V input, if you remember, V output by V input is when you just talk about the value, beta into R output by R input, yes or no? Tell me, yes or no? Right? Right, everyone? This is given, this is given. Okay. Can you find beta? Right? Can you find beta? And after finding beta, we know that power gain is basically beta square into RL by RN. Okay? Okay. So this was the problem of in class. Now, all the problems of 25.2 and 25.1 are easy. If you see this, all the problems are easy. Okay, right? Question number 15. Let's try question number 15. This is the last one that we'll be doing today. Now, if you see the question number 15, right? This is the same configuration that we have used. Yes or no? Tell me. Right? This is the same configuration that we have used. Okay. So what is given? What is asked and what is given? Okay. Common emitter. So what is given? Think about it. Beta, DC given. Okay. RB given, RC given, VCC given, which is your supply voltage, right? VBB can be varied. So V input, this is can be varied. Okay. Assume that when transistor is saturated, VC is 0 and VB is 0.8. Now this is 0.8 given. Okay, you have to calculate minimum base current for which the transistor will be saturated. Tell me guys. Try to solve this one. Okay, this will be the toughest form that you will see in either JEE Mains or NEET. Just try to link everything. You have to find IB, okay, minimum IB. Now, what is saturation current? Tell me, what is saturation current? I hope all of you remember. Saturation current is that current where VCE is 0. Yes or no? Tell me, right? Yes or no? I hope all of you have remembered, right? So when VC is 0, then can I say that VCC is equal to IC into RL? Yes or no? Tell me, yes or no? Right? Now VCC is given. Tell me, VCC is given. RL is given. Think about it. Think about it. So can I say that, okay, IC is equal to VCC, which is 5 by RC, which is 1 kilo ohm. So IC will be what? 5 milliampere. Yes or no? Yes or no? Right? Okay. Now what we have to do? Tell me, guys. Next step would be the answer. So tell me what we have to do now. Simple formula putting getting na. Why we have to find IC? Beta DC is given, right? Beta DC is nothing but IC by IB. Yes or no? Tell me. Right? So just formula putting getting na. IB is IC by beta. As simple as that. Which is 5, right, by 250 into 10 power minus 3. Okay? Put 3 more zeros. 10 power minus 6. It is 20. Yes or no? Tell me. Yes or no? So was this a difficult problem? Tell me, guys, was this a difficult problem? Okay. Now in the same way, you can calculate question number 14. Okay. Right? 14 you can calculate. 15 we have already done. Right, everyone? Okay. So homework is, okay, in next class we will discuss the TPP. Okay. Right? In next class we will discuss the TPP. Plus 25.1 in class, 25.1 homework, 25.2 homework, because there are many good questions in TPP, right? All of you should solve TPP, all of you. Okay. Yes, next class means tomorrow. I'll keep, like, if you need time, I'll keep second class. Wait, let me check. Because most of the question will be logical, right? You don't need have you need not to have spend more time in this.